Welcome to TRICO. I'm Falguni Wheadon, welcoming you to TRICO's 15th edition. Welcome to TRICO 2020. I'm Falguni Wheadon, and I'm delighted to be sitting here with Dr. Grantham. Dr. Grantham, good morning.
Pleasure to be here, Falguni.
If you could very briefly just introduce yourself to our audience.
Sure. It's a pleasure to be here. My name is Aaron Grantham. I'm an interventional cardiologist in Kansas City. That's right in the heart of the United States. In my hospital, Dr. Jeffrey Hartzler, who was a luminary in interventional cardiology practice and set a tradition that's rich in medical education, and I'm pleased to be a part of that. I enjoy going to meetings. I have developed some expertise and a reputation in complex coronary intervention with a focus on chronic total occlusions, and that has been a very enjoyable part of my career, learning how to do that procedure, learning how to teach that procedure in a systematic way, and going out into the world and trying to offer up some solutions to problems that haven't been solved as yet.
Dr. Grantham, we've seen in the last 48 hours in TRICO live cases, some really exciting and very complex cases. Any thoughts on what you've seen so far?
Yeah, I've very much enjoyed the format. That is predominantly case-based with some didactics intermixed. I think that's a unique formula. So many meetings are so didactic heavy without enough case-based learning that I really appreciate the format. And I've enjoyed seeing several cases from operators around the world. Dr. Akasaka has been instrumental in explaining the nuance of intravascular imaging, especially with OCT. That's a modality that I haven't used a lot of, so I've really enjoyed learning that from him and Dr. Tejas Patel, because Tejas has over 600 cases of OCT. He's a true master. He has the image interpreted before it's completely processed. Yeah, that's how good he is, and it's been a real pleasure to see how imaging has been incorporated and how important imaging has been. We've had some specific examples of how imaging changed our case approach, and I think that's an excellent thing for the audience. I also really like the focus on teaching young interventionalists how to be prudent and how to do cases efficiently and how to be judicious in their use of new techniques. There's just been a lot of coaching for young interventionalists. I think that's very important. That if you're not at a specifically designated fellows course, you may be, the teaching may be over your head a little bit, but here there's a specific effort to include advice for young interventionalists. I think that's unique.
And what would your advice be to young cardiologists watching today, either online or from the auditorium?
My advice would be study what people are doing. Try to find advice that is systematic. So many times you go to meetings and you hear things, this is just how I do it. And I think there's not much of that here. There's a lot of, I do this because, and I think that's much more valuable learning. Also, systematic approaches. We've had several discussions about how to approach a bifurcation. I think if a young learner was listening carefully, he could come away with a strategy. He could really understand, he or she could understand when to use a side branch wire for protection, when to use a gel balloon technique, when to expect problems that you want to set up your procedure so that you don't have the problem or that it's easily addressed. I think those things are coming through really brilliantly as part of the live case demonstrations.
And OCT, obviously precision technology, it's really moving our healthcare forward. Modalities such as OCT, which you touched on earlier. We also have robotics. The Apex Heart Institute has seen over 500 procedures being carried out in the last 2 years, which is the most globally. More recently, the 5 cases of the telerobotics, which was very exciting for them, and publication in the Lancet. What are your thoughts on robotics and whether it can take us forward?
Well, robotics are near and dear to my heart because I'm part of the robotics story. And my role is a part-time chief medical officer for Corindus Vascular Robotics, which is now a Siemens Healthineers company. So I have that bias to disclose that anybody should be aware of as I comment on robotics. But I first became interested in robotics in 2016 when the new CEO, Mark Toland, approached me because of the success we'd had in chronic total occlusion angioplasty education, getting people to do these procedures or refer patients for these procedures. We overcame a lot of the old barriers to that happening. Because of that, and because of the struggles with encouraging robotic adoption, because of the expense and many other reasons, Mark came to me to see if I couldn't help try to move the needle forward.
Yes.
And come up with an algorithmic approach like we did with chronic total occlusions, and come up with justifications for people to get involved in robotics. And one of the early experiences I had was to get to meet Dr. Tejas Patel. And it was immediately apparent that this man was a visionary and a pioneer and the kind of person we needed. So it's been a pleasure to watch him flourish and do procedures with regularity and consistency and efficiency. I had the honor to sit behind the cockpit of the robot to do my live case yesterday.
Yes, I was watching actually as you were doing it.
It was just amazing how this team of people who have now done over 500 procedures, 540 to be more precise, performed.
Yes.
I didn't need to say a thing.
Yes.
I just had to say, I'm going to turbo out. I'm going to take the catheter in. Very little discussion needed to happen because there was a symphony going on in front of me of people who knew what to do. And that's how you build a robotics program. You provide your team with regular and consistent procedures, and you do it in a stepwise fashion, beginning with the simplest of procedures and matriculating to more complex procedures. I've even taken the technology into the CTO space, which is my particular expertise from a clinical standpoint. I do about 150 CTO procedures a year. And at least 2/3 of them, I will cross the lesion and then set up the robot to complete the procedure. We've published that data, and about 40% of the time of a procedure is spent in the cockpit, which for me, doing 150 2-hour long, on average 89-minute procedures, adds up to a lot of time.
Yeah.
My interest when Mark came to speak with me was particularly piqued by the fact that the year before that I had a microdiscectomy because I had an acute sciatica problem, a bulging disc that was impinging on a nerve, and I was developing some foot drop. I had that treated and I felt fine afterwards, but I also had 2 episodes of cervical spondylitis, another orthopedic problem that had to be treated with steroids. And when Mark said these benefits, this thing could really help you, but also 40% of interventional cardiologists who have orthopedic problems, we just can't get people interested in it because they're too strong and don't need help. Are you interested? And that's when I became interested, and that's again when I got to meet Dr. Patel and a few other people that I've just had the greatest privilege of knowing.
And watching you yesterday, I was lucky enough to be in the auditorium sitting there. You could have heard a pin drop, literally everybody on the edge of their seats.
Oh, they weren't asleep?
They definitely weren't asleep, I can attest to that. Are there any other technologies that you see coming through that are really exciting you at the moment?
Well, in terms of robotics, the acceleration of technology is unbelievable. We have, as you mentioned earlier, Dr. Patel has done remote procedures. He was sitting in the Akshardham temple with the cockpit and did 5 robotically assisted procedures, while his colleague was in the hospital, in Apex Hospital, doing the device exchanges. And the purpose of that demonstration project was to prove that we could use public Wi-Fi access to execute this remote procedure. And the goal was to make sure that latency was acceptable. That means when you do something in the cockpit, it's executed at the table side 30 kilometers away in less than 200 milliseconds. 200 milliseconds is the threshold for an individual to see that lag between the movements. And we were able to do that. Dr. Patel was able to do that over public 4G Wi-Fi access with a maximum latency of 150 milliseconds, well below the threshold, which gives us proof of concept that this can be done. We've done additional work in a simulator in the United States. We went to Verizon's headquarters and we did simulated cases between Boston, Massachusetts and New York, and then between Boston and San Francisco. And we had an operator, Ryan Mader, who's been really involved in telestenting, do these procedures and then qualitatively assess whether this was from a hard line, a fixed wire connection between these two places, or whether it was over a 5G Wi-Fi network.
Okay.
And he could not tell the difference between the two. Yep. And the latency was always under 200 milliseconds. And so we now traversed greater different distances. And now it's time to move on to larger clinical trials to prove this, because there are other barriers. Latency was the barrier that stopped the Lindbergh operation. That was somebody operating in New York doing a laparoscopic cholecystectomy in France. It was almost 2 seconds of latency. Somebody doing this 2 seconds later, a knife doing that to a gallbladder somewhere was just unacceptable. Sure. So that was the first barrier. That barrier has been broken. It's only going to get better as the whole world goes 5G. And the next steps are to start working on the regulatory issues, the who's responsible issues. It's how do you manage a complication. Equally complex issues that we are prepared to tackle with research and an incremental approach to robotics. So the remote story is an interesting story there, and there'll be progress each year in remote. We also have a real interest in reducing care variability. There's a tremendous amount of care variability in interventional cardiology. You could sample interventional cardiologists from this meeting and find a few different ways to do all the things we do every time. So not everybody can be doing it the best way every time. I mean, there are people who don't believe in imaging.
Yes.
There are people who don't believe that you can help patients with CTOs. Yes. There are people who don't know how to do CTOs, but try to do CTOs. There's a lot of care variability in everything, including which medicines we prescribe for heart failure. Well, if you can use artificial intelligence and you can use automated wire movements, you can elevate care, you can reduce variability, you can come up with best practices and then execute those. And so that's a major goal of the company, and that's, I think, the greatest advantage of this Siemens acquisition is that Siemens holds the most IP patents in the space of artificial intelligence, second only to Google. So they have a very strong interest in artificial intelligence, and I think we needed a collaboration in order to execute that. We have the end effector. We have the device that can execute the movements once they are identified, programmed, are put into an output that a operator can evaluate and to decide, yes, do it that way, or no, I'm going to do it my way. And that way, then physicians are going to be paid for their judgment, not necessarily their skill sets, and hopefully there'll be normalization of skill sets. Skill sets will be more consistent across a multitude of operators.
So I interviewed Dr. Tejas this morning, and we were talking about robotics, of course, and he referred to robotics as the smartest brains coming together. Why would we not do that? You know, he obviously is a great advocate of it, but in the same vein as how you've just described it, let's bring the smartest brains together. The operator is obviously very smart, and that could really be a path forward. What I want to touch on is what robotics means to the layperson. What does it mean for the everyday person? We've talked quite technically, medically, but for somebody watching online today who may not really understand what robotics can actually do for them.
Yeah. So there are two parts to that question. One is, how do patients receive this? Today, you could fly a plane from Ahmedabad to Kansas City with a robot and without a pilot. I wouldn't get on it.
No.
I would be afraid to do that.
Of
I
course.
want a safety mechanism. So when I speak to my patients, first of all, because of my relationship with the company, I have to explain to my patients that I have a relationship with the company. I'm going to do robotics with your procedure. It's an FDA-approved device that I use according to labeled indications. I don't explain to them which stent I'm going to choose or what wire I'm going to do, but I do have to tell them that I'm going to be doing this robotically. I've done over 240 procedures now. That's probably my 241st that I did. And in Kansas City, when I explain this to patients, almost every patient says, that is so cool. They don't start asking, are you going to be there? Sometimes they ask, will you be around? Yes, I'll be around.
So you have a very positive reaction
very
to
positive. I've had
robotics.
two patients say, I don't think so. I'd like you to do it. I'd like you to do it the old-fashioned way.
And what is it about robotics that, in your opinion, why are they saying, yes, that's amazing, that's fantastic? What are the benefits to them?
So at this point in time, there isn't a demonstrated patient benefit. I also explained that to them. I said, this is something I got interested in because of my back problems and because I would like to be here for you longer than I would be had I not used robotics. And they think that's wonderful. People are very altruistic. They're like, Doc, if it's good for you, go for it. They're not really asking me, what's in it for me? There are some advantages. Some of them have been demonstrated in research, and some of them are more theoretical, but there are lower radiation doses for patients and for technicians and nurses in the lab, but especially for the physician. And there's precision.
Yes.
And one of the things that people really like the idea of is that you can move devices with millimeter by millimeter control and be more precise. There's also a very useful measuring function. I was proctoring a doctor in Chennai the other day, and he didn't want to use the measuring function. He said, I'm just going to put in a 38 millimeter stent. I said, well, just do me a favor. I came here to teach you, and while I'm here, I'd love to teach you how to measure the lesions. We measured the lesions, and it was 39 millimeters. So his stent would have been a little short. So we put in a 40 millimeter stent, 48 millimeter stent, so the next largest stent. And he was struck by that. He's like, okay, I got it. He would have missed the lesion. So it was an important lesson for him that you can enhance the precision of the procedure. And that's been demonstrated before with the old first generation device. A doctor named Paul Campbell did a study, and he reduced stent use by about 9%. So there were 9% fewer stents used when systematic measurements were done with the robot. It's not a huge number, but over a career, it turns out to be quite a few stents. So that, in order to demonstrate that's going to help a patient, you'd have to look at an endpoint of restenosis. You use fewer stents, did the stent stay open? That's a massive study that we can't fund, so we haven't been able to do that. I think we'll have our first patient-centered benefit potential in the world of stroke intervention. Right now, in the U.S., there are as many strokes as heart attacks. There are 7,000 interventional cardiologists and 700 neurointerventional cardiologists to do the stroke work. So 4% of eligible patients are getting clot extraction when they have a clot which causes a stroke. That's a very small number. There's a huge unmet need, and the manpower cannot be developed in the next decade. We can leverage physician expertise through remote to execute or to cover a broader network of patients. And I think once that technology, the remote technology, and some approvals for neurointerventional procedures come to fruition, we're going to get to do a study that is going to be, no pun intended, a no-brainer. It's going to save lives. For every 30-minute delay in clot extraction for a stroke, there's $40,000 US dollars in disability. So it's going to win on it should win on an economic level, on a survival level, a patient quality of life level. There should be multiple ways we can demonstrate patient-centered benefits to robotics, particularly with remote.
And talking about the region of India, it's a vast land.
I'm learning.
Do you think robotics can really benefit those in the communities which are further away, give them access to real healthcare? Yeah,
I do think India and countries like China are vastly different from the United States. We've allowed a proliferation of cardiologists in the U.S. that is ridiculous. The median operator volume in the United States is 44 PCIs a year. That would be just, I think, unheard of at most countries where they just don't allow so many interventional cardiologists to graduate and to start to practice. But that means there's lots of underserved areas. In a country with this type of population where you have villages of 500,000 people without a hospital, you could set up a node where there could be the people appropriately trained to manage patients with stroke or with heart attacks. In the U.S., the heart attack story doesn't play out as well because there's enough interventional cardiologists and 80% of people have access to acute angioplasty. There are a few regions, but there are regions of 10,000 people, and for 4 heart attacks a year, you're not going to be able to justify the expense. Those people are still going to have to be shipped. But when you have 500,000 people and no hospital, no healthcare system to care for them, it's a whole different calculus. And if you talk about the disability associated with the delays in getting the care, it should be economically advantageous, and not only that, best for patients. So we see that working outside the U.S.
Very
exciting. In the angioplasty world. And that would also open up opportunities for elective angioplasty as well, if we could set centers up with programs that have enough volume to run both a stable and an unstable PCI program,
Yes.
then I think that would be great for patients who have stable symptoms as well.
Great. And Dr. Grantham, before we have to let you get back to moderating, to the live cases, for you, what drives you each day?
I have been driven by a desire to teach, a desire to add value. That I feel blessed to have been given the opportunity to go to medical school, to graduate from medical school, to be trained in internal medicine and trained in cardiology and get my training from the Mayo Clinic in cardiology and interventional cardiology. I just feel so fortunate to have had those opportunities that I need to pay that back. My father was an academic nephrologist, and my whole life I grew up working in his research lab.
Yes.
I was the only one of his 4 children with an interest in medicine. Everybody else decided to do other things. But that was my passion as a young child. And he once gave me the advice, if the opportunity arises, adopt an orphan disorder. It's something you see quite a bit of, but nobody seems to care about. His orphan disorder was polycystic kidney disease, and he became a world-renowned investigator, and he came up with a new treatment for polycystic kidney disease. And I found that in the chronic total occlusion space. In 2004, I saw a patient that nobody had treated for 3 years. I got lucky and threw a wire across this lesion and opened it, and he came back and he said the words that inspire doctors. It's, thank you for giving me my life back. He knew I hadn't saved his life, but he could walk the dog again, he could play golf again. He got his functional life back. And I said, this is my orphan disorder. I'm going to figure out how to get this done. And I met people. I just kept walking this pathway, and people kept coming in, and it just has grown into, I've made best friends in my life through this, and I've gotten to do things like come here and go to China and everywhere else. And I mean, what's not to love about it? So I don't feel like I planned it. I just feel like I had an idea of something I was looking for. And as things came along, I was able to capitalize, and I just feel really lucky about all that.
And I had the privilege of interviewing Dr. Tejas Patel this morning, and we were talking very much about what drives him as well, and it's this passion to train, to impart knowledge, to be very, very patient-focused, patient-centered. TRICO is obviously his seed that he's grown over the years. Is there anything that you'd like to see in TRICO or Dr. Patel to start investigating further in the future to come?
It's really hard to give advice to somebody who's done so well with such a great meeting. I would offer up maybe a mini program on chronic total occlusions. He has Dr. Saito, one of the Japanese masters, who does done most of the CTO education at the meeting, and there's different philosophies, different approaches, and ways that we could add value, I think, in terms of how to approach patients with chronic total occlusions. I think continuing to demonstrate the power of robotics is an important thing. He's doing that, over and over again. I'm not sure that can get much better, but I'd like to see him have the opportunity to maybe implement some new technologies in the robot at this meeting to bring people in and add excitement to the meeting over new technologies in robotics. I don't have a lot of advice. I hope I get to come back and help the program grow.
I'm very sure you will be invited back. Dr. Grantham, it's a privilege and an honor to have you here for TRICO's 15th edition. Thank you very much.
Thank you. It's a pleasure.